I'm Coach Pete of Math Coach Me. I offer math coaching and tutoring services, and I also offer free lessons and other tools at my mathcoach.me site. This is the ninth lesson in my trigonometry series. We're going to explore the cast rule and reference angles, two very important tools for solving a whole class of trig problems. So, we're going to want to understand those well. Unique to my approach is the use of Desmos calculators like this one to explore math visually, and trigonometry is certainly that, a very visual math topic. Also unique to my approach is there is a online version of this lesson available to you at my mathcoach.me site where you can follow along, where you can take control, you can set an angle. So for this angle of 60 degrees, which is in quadrant 1, I can see that all three of my primary trig ratios are all positive. However, if I were to move this into quadrant, well, let's move it here into quadrant 4 at, or sorry, quadrant 3 at 225 degrees. Here, only my tan ratio is positive. It's positive 1, but my sine and cosine ratios are negative. So why is that? So we'll take a look at that in this lesson. And I do appreciate all the video likes and comments, and certainly the subscriptions as well. So please do consider that. And let's get started. Let's take a look at the cast rule and reference angles. The description for this video does include a link to the online version of this lesson, or you can go to the Math Coach Me site and then to lessons, and there are different filters to filter the lessons, and one is by series. This is the trigonometry series, and locate this lesson, Trigonometry 9, Cast Rule and Reference Angles. And these are two very important concepts for solving a whole class of trigonometry problems where you're solving for theta. So given a problem like sine theta is equal to 1/2, what are all the possible values for theta typically within a domain, like between 0 and 2 pi. So let's get started. The cast rule is a mnemonic that is used to remember the signs of the various trigonometric ratios in each quadrant of the unit circle. To use it, you simply spell out cast, C-A-S-T, but you start in quadrant 4 here. And what these letters tell you is, the A in quadrant 1 tells you that all, A for all trigonometric ratios, sine, cosine, and tangent, are positive in quadrant 1. In quadrant 2, just the sine function is positive. In quadrant 3, just the tangent function is positive. And in quadrant 4, just the cosine function is positive. Now, that's all you need to know. That's all you need to remember to apply this and solve a whole class of problems. However, we are going to just go a little bit deeper to really master this topic. So first, let's explore the cast rule algebraically. What I have in this graphic is I have a 30, 60, 90 in each quadrant, and all in standard position with the 30-degree angle at the origin and the 60-degree angle intersecting with this circle. This circle has a radius of 2, and I know from my special triangle, my 30, 60, 90 special triangle, that the hypotenuse, the relative length of the hypotenuse is 2, and the opposite side of my angle is 1, and the adjacent side of my 30 is root 3. And that's the case for all of these. And that's why this point here is at positive root 3 on the x-axis, and positive 1 on the y-axis. Whereas for this 60-degree vertex, it is at negative root 3 on the x-axis and positive 1 on the y-axis, and so on for my four 30, 60, 90s in each quadrant. Now, let's explore quadrant 2. In quadrant 2, that's a negative 3 on the x-axis, and I should say that the hypotenuse for all of these is just considered positive. It's just an absolute length value of 2. So when I apply the sine of 30 degrees, it is the opposite, positive 1, over the hypotenuse, positive 2, which is 1/2. Whereas the cosine of 30 degrees in quadrant 2 is the negative root 3 divided by 2. So negative root 3 over 2, so it is negative. And the tangent is going to be opposite, positive 1 over negative root 3, so also negative. When I apply that in quadrant 3, same effect, okay? So in quadrant 3, applying the cast rule, only the tangent function is positive. And the tangent function is opposite over the adjacent. The opposite value is minus 1. The adjacent value is minus 3. Dividing negative by negative, we get a positive result. Whereas for the other two functions, sine and cosine, we'd get a negative result. This Desmos calculator provides another way to explore the cast rule, both visually and interactively. So we can see the cast rule has been applied, C in quadrant 4, A, S, and T, working around the quadrants. And we also have a unit circle, and I can change the angle, within my unit circle. And in quadrant 1, I can see that, for all trig ratios, we have positive values, okay? It just remains positive throughout quadrant 1 for all three trig ratios. If I go on to quadrant 2, where the cast rule indicates that the sine ratio is positive, I see that the sine ratio is positive. And for the other two ratios, cosine and tangent, they are negative values. Going on to quadrant 3, applying the cast rule, I can see that the tangent ratio is positive for all angles in quadrant 3 and negative for the sine and cosine ratio. Moving on to quadrant 4, the cast rule tells me that the sine ratio is going to be positive, and I see that, or sorry, the cosine ratio is positive in quadrant 4. And I can see that, and the sine and tangent ratios for all angles in quadrant 4 are going to be negative. This animated graphic provides another visual representation of the cast rule, and we can see our quadrants 1, 2, 3, and 4, going from 0 to 90, 90 to 180, 180 to 270, and then 270 to 360. We can see the sine function in red, and it's positive in quadrants 1 and 2, and then it goes negative in 3 and 4. Our cosine is in purple, and our tangent function is in blue here. And we can see in quadrant 1, all three of our functions are above the x-axis. They are all positive. Going on to quadrant 2, only our cosine function is positive. Moving on to quadrant 3, only the tangent function is positive. And finally, in quadrant 4, only the cosine function is positive. This Desmos calculator shows that the cast rule also applies to the reciprocal functions. So wherever the sine function is positive in quadrants 1 and 2, its reciprocal cosecant is positive in those same quadrants 1 and 2. Same with our tangent function. Our tangent function is positive in quadrants 1 and in quadrants 3, and our cotangent function is also positive in 1 and 3. And for our cosine function, it is positive again. All of them are positive in quadrant 1, but again, it is positive in quadrant 4, and its reciprocal secant function is also positive in quadrant 4. The reference angle is a useful concept for determining the trig ratios for angles that are greater than 90 degrees. So consider this angle theta in standard position. So up until 90 degrees, no problem. You could create a 90-degree or right angle triangle there. But once you go beyond 90 degrees, and this one looks like it's at about 90 plus 45, that's splitting that. So this is at 135 degrees. So beyond 90 degrees, there is no 90-degree angle in this triangle. However, there is here in this one. So for the angle theta in standard position beginning at the x-axis and ending at its terminal arm, there's a corresponding reference angle beta, commonly used beta for that, which does have a 90-degree angle. Okay, so beta, your reference angle, is the angle between the terminal arm of an angle and the x-axis. If we go on into quadrant 3, and this looks like it's 180 plus 45, so that's about 225 degrees for theta. For that reference angle, it is, from the terminal arm, right, to the x-axis, the negative x-axis, and in this case, it could be about 45 degrees. This is the piecewise function for the reference angle beta. So between 0 and 90 degrees in quadrant 1, beta is equal to theta. Between 90 and 180 degrees in quadrant 2, beta is equal to 180 minus theta. Between 180 and 270 degrees in quadrant 3, beta is equal to theta minus 180. And finally in quadrant 4, between 270 and 360 degrees, beta is equal to 360 degrees minus the angle or the degree angle of theta. We can use this Desmos calculator to explore that a little further. We have a slider here to change our angle theta, and we also have a piecewise function here to calculate the value of beta based on the value of theta. So looking at this, when theta is 30 degrees, from here to here, it's 30 degrees. Our angle beta is also equal to 30 degrees, and that's this part of the piecewise function. Between 0 and 90 degrees, when theta is between 0 and 90 degrees, then beta is equal to theta, 30 degrees in this case. Now, let's move this along. Okay, so I've got theta at 150 degrees and beta is calculated at 30 degrees with this part of the piecewise function. So when theta is between 90 and 180 degrees, beta is equal to 180 minus theta. 180 minus 150 gives us our beta reference angle at 30. Going on. Okay, so now theta is at 210 degrees, and that's this part of the piecewise function between 180 and 270 degrees. And our beta angle in that case, our reference angle in that case, is equal to 210 theta minus 180. 210 minus 180 is 30 degrees. Now let's go on to the final quadrant. And here in quadrant 4, this is this part of the piecewise function. So between 270 and 360 degrees, our angle beta is calculated as 360 minus the theta angle. So 360 minus 330, once again, is 30 degrees for our reference angle beta. Two angles are said to be coterminal angles when they share the same initial side and the same terminal side when they're in standard position. So consider a 45-degree angle. Well, it would have a coterminal angle at 45 plus 360 degrees, once around the circle, or 45 plus 720 degrees, twice around the circle. So here's the formula to calculate the coterminal angle of an angle theta. Just add 360 times the number of times around the circle, and also the radian version of that as well. Some properties, some shared properties of a angle and its coterminal angles. First of all the trig ratios are the same. They return the same value. So the sine of theta and the sine of a coterminal angle theta, theta n, is going to be the same, and that applies to cosine, tan, and the reciprocal functions as well. Also, they have the same reference angle. So regardless, 45 degrees and 405 degrees will have the same reference angle of 45 degrees. We can use this Desmos calculator to explore coterminal angles. So I have theta 1 as here in blue, and it's between 0 and 360. And I can use this slider to change its value. And I've got this coterminal angle, theta 2, which is calculated from that. And it's simply theta 1 plus 360 times the number of revolutions. And I can control this slider to control the number of revolutions. So when theta 1 is 30, I can see that, and it's just once around the circle. Okay, so I've set my number of cycles around the circle to 1. So for theta 1 equals 30, theta 2, a coterminal angle, is equal to 30 plus 360 times 1. 30 plus 360 is 390. Okay, and if I change that to, say, 90 degrees, so if theta 1 is 90, then theta 2 is going to be 90 plus 360, which is 450 degrees. Okay, let me set it back to 30 degrees and let me explore this part of it. So if I were to change this so that we went 2 complete cycles around the circle, in that case there, theta 1, or sorry, theta 2, a coterminal angle exists at theta 1, 30 degrees, plus 360 times 2, 720, plus 30 is 750 degrees. So another coterminal angle. And another one at 1110, and another one at 1470, and so on. And if I bring this all the way over to 10 complete cycles around the circle, 10 times 360 is 3600, plus 30 gives us another coterminal angle, 10 revolutions around at 3630 degrees. Notice that regardless of the coterminal angles, we have the same reference angle. Beta 1 for theta 1 is 30 degrees, and 30 degrees for theta 2 as well. And the same sine ratios as well, regardless of the coterminal angles. That remains constant. Finally, to wrap up, the online version of this lesson, and there's a link to that in the video description. The online version does include practice activities where you can explore and practice these various concepts we covered here, coterminal angles, reference angles. There's a practice activities on the cast rule as well. And also you can interact with these calculators. Great way to learn, great way to master these topics. I do appreciate all video likes and comments and certainly subscriptions as well. And I hope to see you again in the next lesson where we're going to take a look at solving for the angle theta.